Welcome. Today, we are diving into the world of descriptive statistics. Now, I know what you're probably thinking. Boring math, endless numbers, confusing charts. But what if I told you it's actually a lot more like a detective story? Seriously, we're about to learn how to use these tools to uncover the hidden stories that live inside every single data set. Let's get into it.
All right, here is our case file. On the surface, it's just a plain old table of numbers from an electronics store in San Francisco. What we're looking at is the number of TV commercials they ran each weekend, and then the sales numbers from the week that followed. It might just look like a random jumble, but the store manager has a really important question. Is there a connection here? Somewhere in this data is the answer, and you and me, we're going to find it.
You know, every good investigation needs a solid starting point. And for us, that means finding the very heart of our data. Before we can even begin to look at the really great weeks or the really bad weeks, we first need to figure out what a typical week even looks like. So, our first question is simple. What's the center of our sales data?
Our first tool for the job is the mean, which you almost certainly know as the good old average. It's really straightforward. You just add up all the values for a category, in this case all of the weekly sales figures, and then you divide that big number by the total number of weeks. And bam, that gives us one single number that represents the typical outcome.
So, we run the numbers for our electronics store, and this is what we get, $5,100. This is our first major clue. On an average week, this store can expect to rake in about $5,100. This number is our baseline, our anchor point for the rest of this whole investigation.
But hold on, the mean isn't the only way to find the center. We've also got the median. All you do is line up all the sales weeks from the smallest amount to the largest, and the median is the one that's sitting right smack in the middle. This gives us a slightly different kind of center, and its superpower is that it isn't easily swayed by a single week with ridiculously high or low sales.
Okay, so we know the average week brings in $5,100, but were all the weeks pretty close to that number, or were they kind of all over the map? See, knowing the center is really only half the story. To get what's really going on with our data, we now have to measure its spread, or, its variability.
And for that, our go-to tool is the standard deviation. You can think of this as a measure of consistency. A small standard deviation tells us that, hey, sales are pretty predictable week to week. But a large one, that means sales are way more volatile, much harder to pin down.
For our data, the standard deviation of weekly sales is $793. So here's what that actually means. A typical week's sales will usually fall within about $800 of that $5,100 average we found. This gives us a so much richer picture of what's happening week in and week out.
Now, this is where the mean and the median together really start to tell a fascinating story. In a perfectly balanced or symmetric data set, the mean and the median are pretty much the same. But if you have a couple of monster sales weeks, they can literally pull the mean upwards away from the median. We call that a skewed distribution, and it's a huge red flag that our average might be a bit misleading. And that's exactly when the median becomes the more trustworthy measure of the center. All right, we have our center and we have our spread. Now for the really fun part of the investigation, finding the outliers. These are the data points that just don't play by the rules, those unusually high or low weeks that totally stand out from the crowd. So are they just mistakes, or could they be clues to something much more important?
To hunt these down, we need a very special tool, the Z-score. Think of the Z-score as a kind of universal translator for data. It can take any data point, like 1 week of sales, and tell us exactly how many standard deviations it is away from the average. It puts everything on the same playing field.
And it's incredibly easy to read. A positive Z-score just means that week's sales were above average. A negative score means it was below average. And a Z-score of 0, perfectly, totally average. The bigger the number, whether it's positive or negative, the more unusual that week was. Simple as that.
Now for data that's roughly bell-shaped, there's this amazing shortcut called the empirical rule. It's a fantastic rule of thumb that tells us pretty much how our data is spread out. About 68% of all our data points will fall within one standard deviation of the mean. About 95% will be within 2, and almost everything, 99.7%, will fall within 3.
Let's use a classic example to see this in action, SAT scores. If the average score is, say, 1,500, and the standard deviation is 300, the empirical rule tells us that about 95% of all students are going to score somewhere between 900 and 2,100.
This rule gives us a super powerful way to instantly get the expected range for the vast majority of our data, whether it's test scores or weekly sales.
And this is exactly how we spot our outliers. Using that empirical rule, we now know that any data point with a z-score way out there, beyond +3 or -3, is exceptionally rare. It's so far from the average that it practically screams to be investigated. It could be a simple data entry error, or it could be a week where something truly unique happened at that store.
So, we've gathered a whole bunch of individual clues: the mean, the median, the standard deviation, and we even know how to spot the weirdos, the outliers. Now, it's time to put all the pieces together and create one single comprehensive summary of everything we found.
We do that with something called the 5-number summary. I want you to think of it as the complete rap sheet for our data. It gives us 5 key data points: the absolute smallest and biggest sales weeks, the median sitting right there in the middle, and these two things called the first and third quartiles. The quartiles are just the points that mark the 25% and 75% thresholds in our data, basically showing us the boundaries for the middle half of all our sales weeks.
And those 5 numbers are used to build a simple but incredibly powerful picture, the box plot. That box right in the middle, that's the central 50% of your data. The line inside is the median, and the little whiskers stretch out to the rest of the values. Any outliers just get shown as individual dots. So in a single glance, you can see the center, the spread, and any unusual data points. It's awesome.
Okay, team. Our investigation of this sales data is pretty much complete. We get it, we understand it inside and out. But we still haven't solved the manager's original mystery. We've been looking at just one variable, sales. Now it's finally time to bring in our second variable, the number of commercials, and connect the dots.
This is it. This is the question that started this whole thing. Is there a real relationship here? Do more ads actually translate into more money? All of our analysis, every single step, has been building up to this final, critical moment. The tool for this final job is the correlation coefficient, and it's represented by the letter R. It gives us a single number, somewhere between -1 and +1, that measures how strongly two things are related in a linear way. A value near +1 means a strong positive relationship. As one goes up, the other tends to go up too. Near -1 means a strong negative relationship. And a value near 0? Well, that just means there's little to no linear relationship at all. And for our San Francisco electronics store, the correlation coefficient between commercials and sales is a stunning 0.93. Wow, that is an incredibly strong positive correlation. It really seems like an open and shut case, doesn't it? More commercials means more sales, right?
Well, here's the final twist in our story, and it is, without a doubt, the single most important rule in all of statistics. Say it with me. Correlation does not equal causation. Just because two things move together doesn't mean one is causing the other. Our strong correlation is a huge clue, for sure, but it is not a confession.
And that leaves us with our final and most crucial question. If the commercials aren't necessarily causing the higher sales, what hidden third factor could be out there pushing both of them up? Could it be something like a holiday season, where the manager naturally buys more ads and more customers are out shopping anyway? This is why we analyze data, not just to find the answers, but to start asking better, smarter questions.